In this section, we are going to address what concurrency and parallelism are and how they are both different from one another. Concurrency is the composition of independently executing tasks. We apply concurrency when we are dealing with handling a lot of things at once. When it comes to concurrency, the focus is on how to structure a solution to solve a problem. The way we solve the problem may or may not be done in a parallel manner. Let's consider a real-world example to better understand concurrency. Picture yourself as a student, and you are assigned a lot of homework in different subjects. You have to come up with a strategy to divide your time so that you can finish all your homework before it is due. Perhaps you will spend a couple of minutes solving a math problem, and then you will read a chapter from your history book, and then you will return back to solving some more math problems. After that, you will read another chapter from your history book. The math homework and the history homework are from two independent subjects that have no relation with one another, and so work for these subjects can be done independently of each other. By switching back and forth between these two subjects, you have interleaved the individual tasks for your math homework with the tasks you did for your history homework in the course of a couple of hours. By dividing your time wisely and getting things done, you have addressed the need to do your homework for different independent subjects in a concurrent manner. Parallelism is the simultaneous execution of computations. It's all about doing lots of things at once. Again, let's picture yourself as a student. You're in a tough math course, and you're in a group study session of 4 people, including yourself. You write the problem on the board, and the entire study group attempts to solve the problem individually before consulting one another on the solution. So the individual 4 brains in the room are attempting to solve the math problem in a parallel manner, where each person is simultaneously attempting to solve the math problem. Let's consider another real-world example to better understand concurrency and parallelism. We've all called a call center before. Maybe we needed technical support or some help with our account details. We are going to consider a scenario where we have a call center with only one call processor. 3 customers call the call center. The first customer wants to report a defect. The second customer needs help on using a feature. And the third customer wants to provide their feedback. The needs of each customer is independent of one another. We only have one call processor, and the call processor has to accommodate the needs of each customer. The processor gives each customer a time slice where they are active in conversation with the call processor. When the call processor decides to move on to helping another customer, the processor puts the current customer on hold and helps out another customer. In this manner, the processor is handling the work of servicing the customers in a concurrent manner. In this illustration, customers 1 and 3 are placed on hold while the call processor focuses on the needs of customer 2. If it takes an average of 5 minutes to handle each customer concern, and it took me 20 minutes to blink my eyes, it would appear as if the call processor was able to simultaneously handle all 3 customers at once. But in reality, the call processor is interleaving the work that's needed for each customer each time the call processor puts them on hold. Because it took me 20 minutes to blink my eyes, I'm not able to see the multiple contextual shifts that the call processor makes between the customers. So, I have an illusion that the call processor serviced all the clients at once, but in reality, the work is being done in a sequential manner, in a piecemeal fashion for each customer. In this scenario, the work can never be done in a truly parallel manner because I only have one call processor that can only handle one customer at a given time. Now, let's consider an example where we have 4 call processors. Now, we are able to handle customer phone calls in a parallel manner. Again, the work that needs to be done for the customers are independent of one another. By introducing 4 call processors, we have 4 processors that are handling the work of servicing the customer calls in a simultaneous manner. In this way, we have work that is being done in parallel. It is important to note that in this scenario, we still have work being done concurrently, because I still have call processor 1 and call processor 4 handling more than one customer at a given time. Only processors 2 and 3 are handling a single customer. Now, with the 2 call center examples that we just covered, I want to make a couple of revelations to help you put the pieces together. Picture the call center as the CPU of the computer. The call processor is an individual CPU core. The customer calling on the phone is an individual operating system process. In other words, the customer can be considered a running program on the computer. In the first example, we considered the concurrent work being done using a single core processor. And in the second example, we considered a quad-core processor, that is, a CPU containing 4 cores. This computer is capable of handling work in a parallel manner, and we also saw that concurrent tasks were being done on it as well. In this video, we defined what concurrency and parallelism are and provided a few real-world examples to help you better understand the difference between the 2 concepts.